Question 1. Truck drivers travel a certain distance and have a rest before traveling further. A driver kept record of the distance he traveled on 8 trips and the amount of time he rested before he continued his journey. The information is given in the table below. So let's have a look at what information is given to us. We know that we're covering distances and we are measuring time for each of those distances, or the rest time for each of those distances. We also know that 8 trips were done by this particular truck driver. So in the table below, they've labeled X as the distances traveled per trip and Y is the time the driver took to rest during each trip. This question has 2 types of data. We call it bivariate data, 2 variables, in this case X and Y. The first question says, determine the equation of the least squares regression line for the data. Now, the least squares regression line refers to regression modeling, and we have a look at regression lines in particular. Now, regression lines have the equation y is equal to a plus bx. So this is a linear regression, and therefore it looks like a straight line graph. So what we have to do is use the data that's been given to us and our calculators to determine the values of A and B. So I'm using a Casio calculator, and I'm going to talk you through the steps to work out regression. Because regression falls under the stats or statistics section, I need to go into my stats mode. So I go mode and 3. And like I said earlier, we're working with bivariate data, means 2 variables, and option 2 is your bivariate. The other clue is that it has the same format as the equation that I mentioned earlier, where we have A plus BX. So I'm choosing option 2. A table comes up just like the table that we have on our screen. This time it's a vertical table, so it'll go from top to bottom rather than left to right. So what I am going to do first is to enter all the X values in, and then I'll enter all the Y values. So the first X value was 180 equals, the second is 200, then 400, 600, 170, 350, 270, and 300. Now that I've entered all the X values, I now have to enter all the corresponding Y values. So let me go to the Y column. As you can see, all the numbers are 0 for now, but we're going to change that using the numbers that appear here. So my Y values are 20 when my X is 180. When X is 200, I have 25. When X is 400, I have 55. When X is 600, I have 120. When X is 170, I have 15. When X is 350, X is 350, so I have 50. When X is 270, I have 40. And lastly, when X is 300, I have 45. Now my calculator stores that data for me, and to do the calculations I need to go into a secondary stats menu. So I will clear my screen, go Shift and 1, and if you look above the 1 it says stats or distribution. So I know I'm looking at a secondary menu in my stats mode. Numbers 1 to 6 offer different things, and I'll show you how to use each of those functions as we answer different questions. 5 is what we're looking at, regression. So this is regression modeling. So I choose option 5. And if you look closely, here's your A and here's your B, which corresponds with the A and the B that's on our question paper. All right, so to choose the value for A, I opt for 1. So A is negative 23,85. So let me write that down. And then let's work out my B value. And all I have to do is again clear my screen, access my secondary menu, choose regression, and now choosing option 2, which gives me my B value, which is 0,227, which rounds off to 0,23. Now remember, we round up to 2 decimal places because that is the instruction given to us on the front of the booklet, unless they tell us to round off differently. Okay, so our final regression line is going to be y equals to negative 23,85, which is my A value, plus B, which is 0,23 times X, because that's the format of my regression line. Question 1.2. If a truck driver traveled 550 kilometers, predict the amount of time that he should rest before continuing his journey. Now we've just worked out the least squares regression line, which was y equals to negative 23,85 plus 0,23x. They're giving us a distance, a new distance, and they want us to predict using our regression line what his rest time should be. Because your distance was your x values, in order to work out your minutes, which is your y value, all you have to do is substitute 0,23 times 550. So let's put that into our calculator. So we said negative 23,85 plus 0.23 times 550. Please type in exactly what you've written down. And it's 102,65. So y is equal to 102,65 minutes. 1.3, write down the correlation coefficient for the data. So correlation coefficient tells us how strong the relationship between your x and your y variables are. The beauty of using your calculator is that all your information is already stored. So if I go to my menu again, my hidden stats menu, and I choose option 2, all the data that I entered earlier is still there. So again, I'm going to clear my screen. I go Shift and my stats secret menu. And even though I am still working with regression, I think I'm going to find my answers in here. So remember, A and B helped us find our least squares regression line. R represents your correlation coefficient. So if I choose option 3, R is 0,98. Right, so that's all they needed you to do. Write down your correlation for the data. Now 1.4 wants us to interpret your answer to question 1.3. So what does this correlation coefficient tell us? We know that the closer to 1 a correlation is, it's really, really strong. And as we move away from 1 and towards 0, then your correlation is weak. So in this case, we are really close to 1. 0,98 is really close to 1. So we say it's a strong correlation. We also have to talk about whether it's a positive or negative correlation. And obviously, this is a positive, so it's a strong positive correlation. Meaning that the relationship between your x and your y variables is very strong. That means your data is very clustered, close to your line of regression. Question 1.5. At each stop, the truck driver spent money buying food and other refreshments, and the amount spent in rands is given in the table below. So if he'd done 8 trips, like was originally stated in the question, there should be 8 pieces of data telling us the cost of the food and other refreshments when he stopped. So the first question says, calculate the mean amount of money he spent at each stop. I want you to notice there's only one type of data here. So when I go into my calculator and I choose my stats mode again, This time, instead of choosing option 2, where there's two types of data, bivariate data, I have a single variable here. It's just money. So I'm going to choose option 1. And option 1 will give me a table that has only X values. And in this case, my X represents the cost in rands. So that's 100, 150, 130, 200, 50, 180, 200, and 190. So there's 8 different values entered into the table. That tells us how many data elements I have. Just like before, I'm going to clear my screen. And let's look at 1.5.1. Calculate the mean amount of money he spent at each stop. So 1.5.1, calculate the mean amount of money he spent at each stop. Mean is X bar. So I'll write it as X. When I say X with the bar at the top, that represents your mean. It is the average if you add up and divide by 8. So all I have to do is add up all these numbers. I'm going to show you a shortcut shortly on your calculator. So I'm adding all of this up, plus 50, plus 180, plus 200, plus 190. And I'm going to divide that by 8 because there's 8 data elements in here. And that's going to give me my mean. Alternatively, because I've entered all my data onto my calculator already, if I go Shift and 1, and this time I choose option 4, which is my variables, I have N, which will tell me the number of data elements. I have X bar. And we've just discovered that X bar will give me my mean. So if I go straight to X bar and press equals, my mean is 150 Rand. 1.5.2, calculate the standard deviation of the data. Again, this is purely calculator work, and therefore it's only worth 1 mark. So again, clear your screen, Shift 1, that's your secret stats menu. Choose for option 4, and number 3 will give you your standard deviation. So this symbol here is sigma. Sigma represents your standard deviation. Choose for option 3, and your sigma, which is your standard deviation, is equal to 50.50 if you rounded it off. 1.5.3. At how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? So let's have a look at the numbers. We have the mean, X bar, which was 150. We have the standard deviation, which is equal to 50.50. And now let's interpret what they want us to find out. We want to know how many, so we're counting in the end. How many stops did the driver spend an amount that was less than 1 standard deviation below the mean, So if I take my mean and I subtract a standard deviation, I'm going to get a number. If I can count all the amounts of money that he spent that are below this number, then I will have how many stops he spent less than 1 standard deviation. So let's go. My standard deviation was, my mean was 150. My standard deviation is 50.5. And if I subtract that, I get 99.50. And if you look at your data, so let's scroll up and have a look at my data. Are there any pieces of data that was less than 99.50? And there's only one. So my final answer is that there was 1 stop where he spent less than 1 standard deviation below the mean. Question 2. At a certain school, the staff committee wanted to determine how many glasses of water the staff members drank during a school day. All teachers present on a specific day were interviewed. The information is shown in the table below. So let's have a look at the table. What we seem to have is 2 columns, column 1 and column 2. And column 1 has the number of glasses of water drank per day. So from 0 to 2, we have 5 people who drink 0 to 2 glasses of water. From 2 to 4, we have 15. From 4 to 6, 13. 6 to 8, 5. And 8 to 10, 2. Question 2.1. Complete the cumulative frequency column provided in a table in the answer book. So I've created a little table here. I've duplicated the information into that table. And now we're going to complete the cumulative frequency table. So cumulative means to accumulate, to add up together. So essentially they want us to add up the frequencies of the data. And the frequency is total number per category. So the first cumulative frequency, because I've got nothing or no interval before it to add to, we assume that the previous interval had 0 members. So 0 plus 5 would be 5. Then I add 5 plus 15 to give me 20. 20 plus 13 is going to give me 33. 33 plus 5 is 38. And 38 plus 2 is equal to 40. So that's a cumulative frequency column completed for us. Question 2.2. How many staff members were interviewed? Well, if you add up all those frequencies, you end up with a total of 40. So 40 people were interviewed. Very basic, quite straightforward. All right, let's look at 2.3. How many staff members drank fewer than 6 glasses? So fewer means less than 6. Now, if you look at all these categories, this is the only category where it includes 6 and goes up to 8, and then from 8 to 10. So when we are looking at fewer, we are looking at less than 6, obviously then less than 4, and then less than 2. So how many in total drank less than 6? 33 is your answer. That's your answer. Question 2.4. So before I start 2.4, I think it's essential for us to read it a few times and see what it's saying, decipher the information, and then look at the solution. The staff committee observed that K teachers were absent, so there were a number of teachers that were absent on the day of the interviews. It was found that half of these K, so that's half, meaning K over 2, teachers drank from 0 to fewer than 2 glasses of water per day, while the remainder of them, we'll work that out in a minute, drank from 4 to fewer than 6, that means between 4 and 6 glasses of water per day. When these K teachers are included in the data, the estimated mean is 4 glasses of water per staff member per day. How many teachers were absent on the day of the interviews? All right, now, obviously the number of teachers they're looking for is this K value. They want us to work out K. So let's have a look at what they said to us. They said that there were K teachers, and half of them lie in the category of 0 to 2. So this is the category they're sitting in, that means in here. So where we had 5 members in that category, we now have 5 plus half of the new teachers, which is K over 2. Then the remainder, now if there were K teachers and I now subtracted K over 2, I'm left with K over 2 because 1 minus half is another half. The other half of the teachers are now sitting in category between 4 and 6, which is this category here. So now I have 13 teachers, which were interviewed initially, plus the other half that were absent on the day. So if you look at our new numbers, we have 5 plus K over 2. We still have 15 in this category. That hasn't changed. We have 13 plus K over 2 in this category, 5 in this, and 2 in that, which remained unchanged by the new teachers. Then they tell us the mean is 4. Now remember, based on question 1, we know how to work out the mean. Mean tells us to add up all the information together and divide by the total number of people. that happened to be here. So before I go any further, if we had 40 people in my initial survey, and now K teachers have been added on, my new total of teachers is 40 plus K. Now, the other crucial thing we need to work out is our class midpoints. Because we don't know how many 1.5s or 1s or 0s are in this category so we can distinguish them, we need to use the average of that category or the midpoint of that category to work out our mean. So to work out the midpoints, it's the bottom plus the top divided by 2. So if I take that and I divide it by 2, my class midpoint is 1. So I call that my xi for now. My class midpoint between 2 and 4, 4 plus 2 is 6, 6 divided by 2 is 3. 4 plus 6 is 10, 10 divided by 2 is 5. 6 plus 8 is 14, 14 divided by 2 is 7. And 8 plus 10 is 18, divided by 2 is 9. So these are my class midpoints. To work out my average, I'm going to take each of these class midpoints, multiply it by my frequency, and add them to the next, and so on and so forth. So to find out my mean, I'm adding a whole lot of numbers together, and I'm dividing it by my total number, which in this case is 40 plus K. So let's start. First, I'm going to take my class midpoint of 1, and I'm multiplying it by 5 plus K over 2. That's my frequency of this category. Then I'm going to add it to 3 times 15, which is the new frequency of that category, plus 5 times 13 plus K over 2, which is the new frequency of this category, plus 7 times 5 plus 9 times 2. Now it looks like a lot, but let's see if we can simplify that. Right, don't forget that all of this is equal to your x bar. What do I mean by x bar? It's equal to 4, because they told us that my mean was 4. So let's go. Numerator will be 5 plus K over 2 plus 45 plus, let's multiply that in to get 65 plus 5K over 2 plus 35 plus 18 divided by 40 plus K. I don't like working with fractions. I'm not sure about you. So I am going to take this over and multiply it across. And to do that, I get 160 plus 4K. And now I can neaten up my numerator. And if you neaten up your numerator, you end up with 3K plus 168. So let me explain. K over 2 plus 5K over 2 is 6K over 2. 6K over 2 is 3K. Now, if you look closely, I've only got K's and some other simple figures to work out here. So if I shuffle things around, K is equal to 8. So there were 8 teachers who were absent on the day of the survey. Question 3. In the figure, L, S, N are the vertices of a triangle having SLN equal to 90 degrees. LN intersects the x-axis at K. So let's have a look at this. So essentially we have a right-angled triangle with a 90-degree sitting at point L. We know that LN intersects the x-axis at K. So that's good enough information. Let's have a look at question 3.1. Calculate the length of SL and leave your answers in third form. So they don't want us to simplify this to a decimal. And all we're doing is looking at the points S and L and finding out its length. So length tells me I've got to use the distance formula. And the distance formula is quite easy to remember. And remember, it's also given to you on your formula sheet. So to find the distance between S and L, SL is equal to the square root. And remember, the distance formula is x2 minus x1 squared plus y2 minus y1 squared. You can choose whichever of your 2 points you want to be your x1 and y1, and then your x2 and your y2. I am going to start with S being my first point, and L being my second point. So to do that appropriately, I will go -4 minus 4 squared plus 1 minus 5 squared. So square root, if you want to use your calculator, you may. Let's do that together. I want to get out of my stats mode. So that's the square root of, please use your brackets, -4 minus 4 squared plus 1 minus 5 squared. And your answer is 4 root 5. So I don't even need my really long surd here. So my answer is 4 root 5 in surd form. 3.2 wants us to calculate the gradient of Sn. So the slope of Sn. Here's S and here's N. So what is the gradient from left to right? So we can see it's a positive gradient. So I'm going to use the gradient formula. So your gradient represented by M, and I'm going to give it a little note at the bottom so I know that I'm finding the gradient of Sn. And the gradient formula is y2 minus y1 over x2 minus x1. Again, you can choose which is your first and which is your second point. I'm going to go with 5 minus -3 over 4 minus -2. So that simplifies to 8 over 6, which is 4 over 3. Question 3.3 wants you to find theta, which is the angle of inclination of Sn. So theta sits here. Theta is always measured from your x-axis in an anti-clockwise direction to your line segment. And that's how you measure your theta. Just like we measure angles in the Cartesian plane, this is the Cartesian plane, and therefore we start on the x-axis and go anti-clockwise. So this is fairly simple. On your formula sheet, you'll notice that tan of theta is equal to your gradient. And we've already got the gradient. We've just worked out the gradient of Sn. So in this case, tan of theta is equal to 4 over 3, and it's a matter of finding theta. So to find theta, go into your calculator. Please make sure that you are in degree mode, so it should say a D at the top. So I'm going to just clear my screen. Shift tan of 4 over 3, close my brackets, and that allows me to convert the ratio to an angle by using shift tan. This is called arctan, and that's 53,13. So remember, we are still rounding off to 2 decimal places as they haven't told us otherwise. So that's 53,13 degrees. (3.4) Calculate the size of angle LNS. So angle LNS is actually sitting here. Now it looks a bit awkward, but we've got lots of information that can help us here. Firstly, we have this 53,13 degrees sitting there, and I think I can use it. What I do understand is that if I have a horizontal line and the angle of inclination to a line segment appears between my x-axis and that line, it doesn't matter where I put a horizontal, all these horizontals will be parallel to each other. And if they are parallel to each other, That means this angle is also 53,13. Now we're getting closer. If I already have 53,13, which sits there, and I can use this angle here to find this angle, then I think we've sorted. But how am I going to find angle beta? Let me call it angle beta because we know that this is equivalent to theta. How would we find angle beta? In order to find angle beta, I need the angle of inclination of this line. If you look closely, it is a line that is sloping negatively, so I know that that's going to be an obtuse angle. So to do that, I first need to find the gradient of Ln. So the gradient of Ln, and that's why I like using my subscripts, so I can tell which lines I'm working with. The gradient of Ln is going to be 1 minus -3 over -4 plus 2, and that gradient simplifies to -2. I knew it was going to be negative. I can see that the slope from left to right is a negative slope, so we're right on point. Now to find angle beta, tan of angle beta is equal to -2. Now we know that when there's a negative gradient, we are going to get an angle in the reverse direction, so we need to do an adjustment on what we end up with on our calculator. So let's have a look. If I go shift again tan, and this time I'm looking at -2 as my gradient. Remember, I'm going to get a negative angle because I will end up measuring in the opposite direction. So let's go to our calculator, shift tan, so that's tan inverse, make sure the -1 appears, of -2 is -63,43. So -63,43 is actually this angle here, but that's not the one I'm looking for. I want that obtuse angle starting from the positive x-axis and moving all the way to line Ln. So to adjust that, all I have to do is add 180, and I get 116,57. So beta is equal to 116,565. I'm not going to round off yet because I still need to do more calculations. And if I'm not at the end of my answer, I cannot round off. I only round off at the very end. So like I said at the start, if I want to find this angle here, LNS, I've got to take beta, which I've just found, angle beta, and subtract theta, which was the 53,13, and that would give me 116,565 minus 53,13. I can use a rounded answer here because I'm bringing it from a previous question, and my final answer is 63,44 degrees. Question 3.5. Determine the equation of the line which passes through L and is parallel to Sn. Write your answer in the form of y equal to mx plus c. All right, so we're finding the equation of a straight line. Let's see what information we have about the straight line. We know that it passes through L, so it takes its x and its y value from point L. We know that it's parallel to Sn, and that means it takes its gradient from Sn. So that's two vital pieces of information. Let's have a look at what this would look like if I drew it on my diagram. So I'm just going to play around here. I know that the line is parallel to Sn, but doesn't pass through S or N. It actually passes through L. So that's what it looks like. So there's a line that is parallel to Sn and passes through the point L. So let's have a look at what we have. We have L, which is equal to -4 and 1, And we've already determined that those are your x and your y values. But we have another piece of information, which is the gradient of Sn. The gradient of Sn was equal to, and we calculated this earlier, 4 over 3. So if you look at it, we have y equal to mx plus c, and we have three pieces of information that will help me figure out this equation. We've taken care of m, so it's essentially finding the value c. I'm going to substitute my x and y values into here. So y is 1, my gradient is 4 over 3, and I'm multiplying that by negative 4 plus c. Simplifying this, I'm going to end up with c is equal to 19 over 3. And therefore, y is equal to 4 over 3x plus 19 over 3. Question 3.6, calculate the area of triangle LSN. I think that they were very generous with us. I think because they gave us a right angled triangle, they wanted this to be easy. So remember, if it's right angled, all we have to do is work half base times height. You could use the area rule as well, but essentially you still need these two lengths. You could also use these two lengths because you also have that angle. So there's many ways in which you can find the area of this particular triangle. Because it's right angled, I'm going to go with half base times height. We have already worked out SL in the first question, and we worked out SL to be 4 root 5. So we have the 4 root 5 here. All I need now is Ln, and to find the distance or the length of Ln, I can use the distance formula, which in this case is negative 4 plus 2 squared plus 1 plus 3 squared, and that simplifies to 2 root 5. So area of triangle LSN is equal to half of Ln times SL. So let's put those numbers in. Ln is equal to 2 root 5 and SL is equal to 4 root 5. And my final answer is then 20 units squared. Area is always squared. Question 3.7 says calculate the coordinates of P, which is equidistant from L, S, and N. All right, so P obviously is not on our diagram, so I'm going to plonk a P somewhere with the coordinates X and Y because it's a point in the Cartesian plane. What we do know is that it's equidistant from L, S, and N. That means if I draw a line from L to P and then a line from P to N, those two lines are equal distance apart. And similarly, that is equal distance apart. Now, it doesn't look like it, so obviously P has to move around a bit to be that point. Now, if we look closely, there's only 3 marks to this question, so it can't be that difficult. So let's start looking at a cleverer way to answer this. Let's take away what we've just drawn in and see what they've given us. They've given us a right-angled triangle. Now, we know that right-angled triangles also happen in another space. And if I start introducing circles to this space, and let me see if I can get this right. If I place the circle in such a way that Sn is my diameter, then we are using the converse theorem of angles in a semicircle. So look how neatly that passes through the center of the circle and that's 90 degrees at the circumference of the circle. So even if we didn't intend for it to be the diameter, if you circumscribe those 3 points, circumscribe means to draw a circle to include all 3 points on the circumference, and that is 90 degrees, then that has to be the diameter, and that's your converse, angles in the same segment theorem. So if that's the diameter, then that means this line passes through the center. So the center sits somewhere here. If I call that point P, let's see if it goes with the logic of being equidistant. If that is the center, then P to S is equal to P to N, which is what we said so up here. All we need to know is whether LP is equal to those two line segments. So if I draw a line from L to P, well, if P is going to end up being the center, then automatically these 3 radii are going to be equal to each other. So in concluding that, how then will we find point P? Well, if P is the center and subsequently the midpoint of the diameter, then all we have to do is to find the midpoint between S and N. And that's quite simple to do. All you have to do is add the x's and divide by 2, add the y's and divide by 2. So, what are the coordinates? 4 minus 2 over 2 and 5 minus 3 over 2. And the coordinates of P become 1 and 1. And for 3 marks, that's what is expected of you. All right, question 3.8. Calculate the size of LPS. LPS is this angle sitting here. All right, I think this is why the circle was so important, because if you look closely, if that's your angle at the center, then it's related to the angle at the circumference. And we found angle LNS earlier. So angle LNS we calculated to be 63,44. If you scroll up, you'll be able to see that. So that's 63,44. So therefore angle LPS is going to be double that, which is 126,88 degrees, and your reason is angle at center is equal to 2 times the angle at circumference. Question 4. In the diagram, the circle with center O has the equation x squared plus y squared equal to 20. G, which is T0, is the center of the larger circle. A common tangent touches the circles at D and F respectively, such that D, which is P minus 2, lies in the 4th quadrant. Okay, so let's decipher what's been going on. We have 2 circles here. The smaller circle has the equation x squared plus y squared equal to 20. We can see that it's centered at the origin. The big circle has a center of G, which is T and 0. That means your center is sitting on your x-axis, essentially cutting your big circle in half. There's a common tangent. So this tangent here passes and touches each of those circles at F and D, and that's what they mean by respectively, first at D and then at F. And they say point D, which is the point of contact with the tangent and the small circle, has the coordinates P and minus 2. All right, we'll get to that in a minute. And it lies in the 4th quadrant. Obviously, they told us that for a reason. So, let's have a look at question 4.1. Given that D, this is question 4.1, given that D, which is P minus 2, lies on the smaller circle, that's the small circle, show that P is equal to 4. So the equation of that circle is x squared plus y squared equal to 20. That means if I substitute my x and y in here, which is p squared plus negative 2 squared equal to 20, I get p squared plus 4 equal to 20. P squared is equal to 16, so P is equal to plus or minus 4. Now remember, they told us that D lies in quadrant 4. And in quadrant 4, x is positive and y is negative, so your P value can only be equal to positive 4. Question 4.2. They say that E is the midpoint of DF. So E is at this point here, is the midpoint of DF. So that has the coordinates 6 and 2. We've worked out D to have the coordinates 4 and negative 2. And if E is the midpoint of DF and they want us to find the coordinates of F, I'm going to call that X and Y again and see what happens. So to find the midpoint, we add the two X's and divide it by 2, and then the two Y's and divide that by 2. So essentially, if we are looking at E being the midpoint of DF, X plus 4 divided by 2 is actually equal to 6. That means X plus 4 is equal to 12, so X is equal to 8. Similarly, Y minus 2 divided by 2 is equal to is equal to 2. So Y minus 2 is equal to 4, so Y is equal to 6. So the coordinates of F are now 8 and 6. Question 4.3. Determine the equation of the common tangent df in the form y equal to mx plus c. So here's your df. It's a tangent to both circles, and fortunately for us, d and e are points on that straight line. So if you look at the graph y equal to mx plus c, your m is your gradient and your c is your y-intercept of that line. So to find the gradient is equal to y2 minus y1 over x2 minus x1. And you can choose which of your points is your first point and which is your second. So I'm going to go 2 minus negative 2 over 6 minus 4, and I end up with the gradient of 2. So now that I have my gradient, I can choose either D or E as my x value and my y value. So I'm going to choose point E. So my x is 6 and my y is 2. So if I substitute all of those into my y equal to mx plus c, the only outstanding variable is going to be c. So I have 2 is equal to my gradient, which was 2, my x value, which is 6, and my c value is my only unknown. And solving for c would be equal to negative 10. So the equation of that tangent is y is equal to 2x minus 10. Question 4.4, calculate the value of t, show all working. So where's t? T is actually sitting here on the x-axis. It is the center of the largest circle. So let's have a look at what information we have. We have the points D, E, and F. We've also just figured out that this equation here is y is equal to 2x minus 10. So we're going to try and use some of the relationships we've learned to work out point T. Now, I know that if this gradient here is equal to 2, and this is your line from center to your tangent, I also know that those two lines are perpendicular to each other. So that's 90 degrees. And if that's the case, because your tangent is perpendicular to your radius, if that's the case, then the gradient of FG is equal to negative half. So let's use that information. So we know that the gradient of DE was equal to 2. Therefore, the gradient of FG will have to be equal to negative half. And the reason is tan perpendicular to your radius. And you have to write down your reasoning when you're using geometry reasons to answer coordinate geometry questions. So if that is the case, and I have point F and I have parts of point G, I can use that gradient information to work out t. So the gradient of fg is equal to negative half. So let's work that out. That means 6 minus 0 over 8 minus t is equal to negative half. So if we simplify that, we end up with 6 times 2 is equal to negative 1 times 8 minus t. So 6 2s are 12. You get negative 8 plus t on the right-hand side. I'm going to move my negative 8 onto the left-hand side. So this negative 8 is going to move over here to become 20 is equal to t. And that's your answer. Question 4.5. Determine the equation of the largest circle in the form ax squared plus by squared plus cx plus dy plus e. So they essentially want us to find the equation of this large circle here. And in order to do that, I need two things. I need the center of the circle. And we've just worked out the value of t, which is 20. So we've got 20, 0 as point G. So that means I do have the center of the circle. And I need the length of the radius. And that's quite simple to find if I already have the points of contact, which is F, and my center, which is G. So the first thing I am going to do is to work out the length of FG, which is my radius. So FG squared, because I don't want to use the third, FG squared is equal to 20 minus 8 squared plus 0 minus 6 squared. So FG squared is equal to 180. Okay, so now I have the length of the radius squared, and I have the center of the circle. So if I put that into my equation, x minus 20 squared plus y minus 0 squared. You don't have to write the minus 0. I do it to make a point. And my radius squared is 180. All right, now they don't want it in this form. They want us to expand this out. So I am going to multiply out to get x squared minus 40x plus 400 plus y squared is equal to 180. So they want us to have a 0 on the right-hand side. So I'm going to bring that over onto the left. So x squared plus y squared, because that's what they wanted here. Then my cx, which is negative 40x, and 400 minus 180 is 220. And there we have the values of A, B, C, D, and E. 4.6. The smallest circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. So essentially, translating means to shift something left or right or up and down. But because they say along the x-axis, we know that we're going just horizontally. Right, so they want the small circle here to be shifted along to the big circle, but it must touch on the inside of that circle. In other words, it mustn't overlap on the outside, and it mustn't sit on the circumference of the circle. So let's have a look at the small circle. This is a replica of that small circle. I'm just going to put it in there so you understand what I'm talking about. We know that this equation of the circle is x squared plus y squared is equal to 20. So the radius squared is equal to 20. So the radius is equal to 2 root 5. So this is the radius of the circle. Now it's important that you know that that radius can be on either side of that circle. So in other words, this little green line can be from there to there. And I want to make a point about that. All right, so what we are actually trying to do is we're trying to take this circle and we want to shift it. I just want to group these together so they'll move nicely. All right, so I can move it across. They want me to move it, slide it across so that it just touches on the inside of the big circle on that side and then touches on the inside of the big circle on that side. So let's think about this. Now, I think important points are your two x-intercepts. Now, I'm going to try and get there intuitively, but you could solve for x because you've got the equation of the big circle. I know that the radius of the circle here is the square root of 180. And the square root of 180 is 6 root 5. We worked it out in the previous question. That means if my center is sitting with the x value of 20 and I move 6 root 5 units to the right, this coordinate is 20 plus 6 root 5. And then if I move 6 root 5 units to the left, this coordinate here is 20 minus 6 root 5. So those are the two x-intercepts. Now let's take our circle and place it here. And let's have a look at this question more reasonably. This point to that point, the distance is 20 minus 6 root 5. But if I want to move this entire circle so that it sits on the inside of the big circle, that means I'm moving it 20 minus 6 root 5. And if I did that, it sits about there. But I want to move it further so that it sits on the inside. That means I'm moving it another 2 root 5 units away. Okay, so my first k value is to that x-intercept, which is 20 minus 6 root 5, plus another 2 root 5 to make sure the entire circle fits on the inside. Now let's look at moving that circle across to the other side, because I still need to compensate for what's happening here. So here, all I'm doing is taking the circle from here and moving it all the way across to there. All right, again, from here all the way across to there. Now, even though it seems like I'm moving it 20 plus 6 root 5 units, I want you to notice something. If I place the circle here, the distance between 20 root 5 and this point here is not the entire x-intercept value, right? So my k value, if I'm going to shift this graph, k is equal to 20 plus 6 root 5, which is correct. And if I moved it all the way there, that would be correct. However, that means this point here is coinciding with that. And I have to subtract this portion was already part of that 20 plus 6 root 5. So I have to subtract 2 root 5, which is the length of the radius. So k is equal to 20 minus 4 root 5, or k is equal to 20 plus 4 root 5. Question 5.1. Given that sine of beta is equal to 1 over 3, where beta lies between 90 and 270, without using a calculator, determine each of the following. So first, let's decipher what's given to us. I have sine of beta, so my angle is beta, and my ratio of that angle in a triangle is 1:3. What we also notice is that sine has a positive ratio, so bear that in mind. And beta lies between 90 and 270. So what I am going to do is work with the Cartesian plane. Remember, that's 0, 90, 180, 270, and up to and including 360. All right, and we are working between 90 and 270. Between 90 and 270 are in these two segments. So I'm going to put a little tick here and a tick there. Then let's have a look at sine of beta equal to 1/3. So that's a positive. And sine is only positive in quadrant 1 and quadrant 2. So the overlap is actually occurring in quadrant 2. That means I can draw my right angle triangle here, right angle triangle there, and beta is measured from 0 to the second quadrant. So it's an angle that is obtuse, it's greater than 90 degrees, and that's my beta. I was given the ratio of 1:3, so we know that sine is y over r. So sine of beta is y over r. That means your y value is 1. your ratio is 3, and using the theorem of Pythagoras, I'm going to find out what my x value at this point is. So if x squared plus y squared is equal to r squared, I don't know x. I do know that my y value is equal to 1, and I know that my radius is equal to 3. So x squared is equal to 9 minus 1. X squared is equal to 8. Therefore, x is equal to plus or minus the square root of 8, which is 2 root 2. So x can be positive or negative, but because we're sitting in quadrant 2, we know that this x value is negative 2 root 2. So to work out cos of beta is equal to x over r. Your x value is negative 2 root 2. And your radius is equal to 3. All right, let's look at the second question, 5.1.2 in this continuation. Sine of 2 beta. Now, we don't have 2 beta in here. We just have beta. But we can expand this using the double angle formula for sine. So sine of 2 beta is equal to 2 sine beta times cos beta. And we know that sine of beta is equal to 1/3, so I substitute it in there. Please note that the entire function and its angle is substituted with a ratio. So you're not going to write down sine of 1/3 or cos of the next one. You've already worked out cos in your previous question, so that's negative 2 root 2 over 3. And now it's a matter of simplifying this expression. So my numerators, remember this is equal to 2 over 1, is negative 4 root 2 all over 9. If you didn't simplify this to root 2 and left it as root 8, this can be written with a root 8 anyway, 2 root 8 if you needed to, because it says without a calculator, so the leniency will apply in this case. 5.1.3, cos of 450 minus beta. Now 450 bugs me because it's more than 360, so a simple rule is if you've got an angle that's larger than 360, keep subtracting 360 until you get to an angle that's less than 360. So we are fortunate in that if we subtract 360 from 450, we end up with 90. And 90 is less than 360, so I didn't have to go one more step. Cos of 90 minus beta. Now, when we have complementary angles like 90s and 270s, your function will change to its co-function. So cosine changes to sine. And you look at the original function and determine whether that will remain positive or negative. But because we are 90 minus, that means we are in quadrant 1, and cos is positive in quadrant 1, we don't have to worry about whether the sign changes from positive to negative or negative to positive. So in this particular case, co-function changes the function to its co-function. That's your complementary angle. So this will become sine of beta. And sine of beta is quite simple. It's equal to 1 over 3. Given that cos to the power 4 plus sine squared x plus cos squared x over 1 plus sine x. So we're given a trig expression here. It's a fraction. And 5.2.1 wants us to prove an identity. In other words, we've got to take the left-hand side and work towards achieving the right-hand side. So let's have a look at the left-hand side. The left-hand side in this case is cos to the power 4 of x plus sine squared x times cos squared x. Divide that by 1 plus sine x. Right, now let's have a look at the numerator. We need to try and simplify that. There's a lot going on. I'm not used to working with power 4s, but I do work with square identities. But let's see what I can do. What I do notice is that cos squared is actually a common factor to those two terms. So I'm taking it out as a common factor, cos squared x. And that leaves me with cos squared x plus sine squared x in the bracket. That's nice and convenient. And my denominator is 1 plus sine x. Now cos squared x plus sine squared x is equal to 1. So that means in the numerator, all I'm left with is cos squared x times 1 over 1 plus sine x. Now that still doesn't look like my right-hand side of this expression. I need to get it to 1 minus sine x. And right now I'm sitting with the cos squared at the top. I do know that cos squared is actually 1 minus sine squared x. It seems like we're getting somewhere now. But I still have a 1 plus sine x in the denominator. All right. Fortunately, if you look closely at the numerator, that looks like a difference of two perfect squares. So I'm going to factorize that to be 1 plus sine x into 1 minus sine x. Okay, if I sound like I'm getting louder, it's because I love trig and I get excited when I do trig. Right, and 1 plus sine x at the bottom. Those two will cancel out beautifully. Ah, look at that. I have 1 minus sine x, which happens to be equal to my right-hand side. So we've proved the identity where my left-hand side simplified to create my right-hand side. 5.2.2. For what values of x in the interval 0 to 360 is my expression undefined? Now, undefined is a tricky one. Undefined only happens if my denominator is equal to 0. So, when would my denominator equal to 0? When x lies between 0 and 360 degrees. So, let's solve this equation. So, I end up with sine x equal to negative 1. Finding my key angle or my reference angle, I end up with negative 90. So what are my terms going to be? Well, x is equal to negative 90 plus k360 if I'm working out general solutions. And I like to do my general solutions before I go to specific. Or it is 180 minus negative 90 plus k360. All right, so that means x is equal to negative 90 plus k360, or x is equal to 270 plus k360. Now, this is how I like to narrow down my solutions. I'm going to my calculator. I will go into my table mode. My table mode will allow me to actually generate the solutions. So if you haven't done this before, watch exactly what I'm doing because I think we'll need it later on in this paper as well. So first I'm typing in negative 90 plus 360 alpha x. My x here is replacing the k there because I don't have a k to work with on my calculator. For g of x, I'm putting in the second solution, which is 270 plus 360 alpha x. Again, x representing my k value. I will start substituting from negative 5. That means k is going to take on a value from negative 5 to 5. And I'm stepping up in ones because k is always an integer. So what my calculator does now, it generates a whole lot of angles, both columns. All I have to do is to pick out the numbers that lie between 0 and 360. If the domain was different, if the domain was negative 360 to 360, then you'll pick out all the numbers that lie between negative 360 and 360. So here my first solution is sitting at 270. My second solution is still 270. Are there any others? I can't see any others. And so my only solution is 270 degrees. Therefore, x is equal to 270 degrees. So this expression is undefined when x is 270. Let's see why that is. Well, if I put in 270 here, sine of 270 is equal to -1, and 1 minus 1 is then 0, and that makes it undefined. 5.2.3, we are still working with the same expression. It says write down the minimum value of the function defined by this. Now, in 5.2.1, we figured out that this is actually equal to 1 minus sine x. That's what we worked towards. So essentially, y is equal to negative sine x plus 1. It's the same expression, I've just swapped those two terms around. And the reason I've done that is because when they start talking about minimum values and maximum values, it takes me straight back to a graph. So if I sketch a simple sine graph, I'm just going to go from 0 to 360 and see what happens. If I sketch a simple sine graph, sine of x graph, or a negative sine of x graph, my negative sine of x graph is going to look like this, right? With a minimum value at -1 and a maximum value at +1. Let me just write that properly. A maximum value at +1. All right, now this is not the graph I'm actually looking at. I'm looking at negative sine x, which is this graph, plus 1. That means I'm shifting this graph horizontally. In which direction? Good, upward. So if I take this and I move it there, well, actually sitting there, that's what my graph will look like, with my minimum value actually sitting at 0. Now, if I go back to where it was, if negative sine x has a minimum value at -1, and I add 1 to -1, my new minimum is equal to 0. 5.3, given that cos of a minus b is equal to cos a times cos b plus sine a times sine b, use the above identity to deduce that sine of a minus b is equal to sine a cos b minus cos a sine b. So let's start with what they want us to simplify. We want us to simplify sine of a minus b. But they want us to use the cos. Now, how do I change sine to cos? Well, I use its co-function and its complementary angle. So if I'm changing sine to cos, that means I now have to introduce a 90 minus whatever the angle was. All right, and I'm going to do some manipulation here now. Essentially, I'm going to subtract each of these angles here. So watch this. It'll be cos of 90 minus A minus negative B. Does that make sense? Because I've distributed the -1 into that bracket. In doing that, that allows me to put these two together. Now I have an angle here and an angle there, and I can mimic what this expression is telling me to do. So cos of A minus B, which is A minus B, is cos of the first angle times cos of the second angle. In this case, my second angle is -B, plus sine of my first angle times sine of my second angle, which is -B. Remember, because I have to use this expression here, I have to mimic the angle minus the angle to solve it. So let's simplify. Cos of 90 minus alpha is sine alpha. Cos of negative beta, remember, negative beta is in quadrant 4. And cos in quadrant 4 is positive cos beta. Right, let's look at sine of 90 minus alpha, or minus A, will become sine of A. Sorry. Sine of 90 minus A becomes cos of A. And sine of minus B, again, sine is negative in quadrant 4, so it becomes negative sine B. Right, let's neaten that up. So I have sine A times cos B minus, because they're positive and a negative, cos A times sine B, which is what they wanted us to prove. 5.3.2, hence, or otherwise determine the general solution of the equation sine 48 cos x minus cos 48 sine x is equal to cos of 2x. Now, if you look at the left-hand side of that equation, that's essentially the expansion of what we've just done. So if you look closely, we've got sine of an angle cos of beta minus cos of an angle times sine of beta, which is exactly the same pattern. And if that is the pattern, then that reduces to a quite simple expression. So let me write this down. I've got sine 48 times cos x minus cos of 48 times sine x equal to cos of 2x. I'll deal with the cos of 2x shortly. But the left-hand side is going to simplify to sine of 48 minus x, and my cos of 2x I'm going to leave as is for now, and then we'll have a look. Right, so I've got a nice simple expression on the left hand side, sine of 48 minus x, and we've got a cos 2x on the right hand side. Now the only way we can solve this is two tricks: either changing the sine or the cos to its cofunction, sine theta changes to cos theta, or cos theta changes to sine theta. Or we can change this entire equation to include a tan, but that can only happen if these two angles are equal, and they're not equal. So I have to resort to a second type of solution. That means I have to change either this sine to cos or that cos to sine. I prefer to change this to cos, and if I do change it to cos, I have to introduce my complementary angle. And now I've got coses on both sides of my equation. Right, 90 minus 48 becomes cos of 42 plus x, because that negative distributes into that bracket. And I have cos 2x on the right-hand side. Now, we've got an expression with the cos on the left and the cos on the right. And what I like to do is I make either one of these my reference angle. So I'm going to call this here my key angle. So now I'm going to end up with a general solution for this particular equation. Right, so according to my rules, I'm going to go 42 plus x is equal to plus or minus my key angle, which in this case is 2x, plus k360. And remember, k is an element of integer. Right, now I need to solve this. I've actually got two equations here, so I'm going to separate them and solve them separately. 42 plus x is equal to 2x plus k360, and 42 plus x is equal to negative 2x plus k360. All right, bringing the 2x over onto this side, I have negative x equal to negative 42 plus k360. So x is equal to 42, you can say minus k360, but I can leave it as positive k360 because the k will absorb the positive or the negative. Right here, bring this over, I end up with 3x equals to negative 42 plus k360. And now I'm going to divide by 3 to give me negative 14. And you divide this by 3 as well. Don't forget that. That becomes 120. And remember, you've already said k is an element of integer. Right, if you did this using changing the causes to signs, you would end up with the same solutions. 5.4. Simplify sine 3x plus sine x over cos 2x plus 1. All right, let's have a look. I have sine 3x plus sine x over cos 2x plus 1. All right, we don't know a triple angle formula yet. We only know double angles and we know compound angles. So I am going to use the compound angle to expand my sine 3x. So if I write sine 3x as sine of 2x plus x plus sine x, I should get somewhere. Right, in the denominator, I have cos of 2x. Cos of 2x has 3 different expansions. So I'm going to choose cleverly. I know that if I choose the expansion that has a minus 1, then it will cancel this positive 1 out. So I'm going to choose 2 cos squared x minus 1 plus 1, and those two will cancel each other out. Right, let's expand the sine 2x plus x. So that becomes sine of 2x times cos x plus cos of 2x times sine x plus sine x. Right, in the denominator, like I said, those ones will cancel. So you have 2 cos squared x left behind. Right, let's look further. Now notice that there's a double angle here and a double angle there. So I want to expand each of those double angles. I'm going to leave the cos 2x for a while just to see what happens after I deal with the sine 2x. So remember, sine 2x will become 2 sine x cos x. I'm putting that in a bracket just to prove a point because I mustn't forget that there's another cos x sitting there. Or maybe I will expand the cos 2x, but I'm not sure what to expand it to. So again, I'm just going to leave it until I see what my other terms look like. Remember, if there's another 1 that appears, I can choose the expression with the minus 1. Or if there's a negative 1 that appears, I can choose the expression that has a positive 1, and so on and so forth. Right, so then I have sine x there, and in the denominator, I've got 2 cos squared x. Right, so I'm going to take this as 2 sine x cos squared x. So there's a cos squared in there. But I notice that all 3 of these terms have a sine x. And if I take out a sine x, then I'm left with the 2 and the coses. So that's 2 cos squared x plus cos 2x. Again, I'm scared to change this one just yet. So let's see what happens. And then sine of x becomes plus 1. That gives me a little hint of what's going to happen next. So I've got 2 cos squared x there. Right, I am going to choose to expand that cos 2x, this cos 2x here, to one that has a negative 1, because then I can get rid of that. So I have sine x into 2 cos squared x plus, let me use a different color, 2 cos squared x minus 1 plus this other one sitting there, all over 2 cos squared x. Right, doesn't seem to have gotten us further, but I'm happy to say those two will cancel out. And these two are actually like terms. So I have sine x And then I have times 4 cos squared x all over 2 cos squared x. Ah, look at that. Those two will cancel. 2 will go there once and 2 will go there twice. So my final answer is equal to 2 sine x. Question 6. In the diagram, the graphs of f of x, which is 2 sine x, so that's this graph here, and g of x, which is negative cos of x plus 45, is that graph there, are drawn for the interval 0 to 180. Point A is 105 degrees and negative 1, and they want us to write down the period of f. Now, f period is pretty obvious because it starts with the crest and then ends in the trough. It's a complete wave. So that wave takes 180 degrees to complete, and therefore the period of that graph is 180 degrees. 6.2, determine the range of G in the interval 0 to 180 degrees. So here's G. G is sitting here. Range is how high and how low does it go. Now, we can see that the maximum is sitting at positive 1, but we're not sure about this minimum value here. What I do know is that this minimum happens to be on the y-axis, and that's where x is equal to 0. So the equation of that graph is y equals to negative cos into x plus 45, x plus 45, right? And we've just established that at this point here, your x is equal to 0. So y is equal to negative cos of 0 plus 45, and that will be negative root 2 over 2. So this value here is negative root 2 over 2. So your range starts at a smaller value of, or your smallest value of negative root 2 over 2, and your maximum value of 1. 6.3, determine the values of x in the interval x in element from 0 to 180 degrees for which f of x times g of x is greater than 0. The only time a product, when you multiply two things together, will be greater than 0 is when both are positive or both are negative. So let's have a look at where f of x is positive. So f of x would be positive. Let's have my highlighter. F of x is positive there. So we now need to look at when is g of x positive. G of x is positive there. So the only overlapping time that they are both positive is between 45 and 90. Let's have a look at where both graphs are now negative, because if both are negative, then we will have the second version happening. So g of x is negative between 0 and 45, but f of x is negative between 90 and 180. There's no overlap as to when both are negative. So there is only one particular solution for this one. That means between 45 and 90 is where our x values lie. We will use round brackets because it's not including. We don't have equals to 0. It's from 45 to 90, excluding those degrees. 6.3.2 wants to know when is f of x plus 1 less than equal to 0 for where x lies between 0 and 180. All right, so let's manipulate this a little bit because I have f of x, which is 2 sine of 2x. So I know that if I take f of x and leave it on the left and I move the 1 over, I get when is f of x less than or equal to negative 1. Now, f of x represents your y value. So here's a negative 1 here. So they gave us an x value. They were kind enough to give us a hint here. So f of x being your sine graph, I want to now create another graph for where y is equal to -1. And I want you to see that the graph of f lies between or below the red graph, the -1 graph, between x equals to 105 and this other number sitting there. And that's what we need to figure out. What is the x value at that point? So the x value here. Okay, so here's simple logic. If this is 90 degrees, and that's 15 degrees away, that's how I get to 105. Then if this is 180, then that's 15 degrees away there as well. So if this x value is 105, then that x value has to be 180 minus 15, which is 165. So when is your f below -1? When x lies between 105 degrees and 165 degrees, but we can also include because of the equals here. (6.4) Another graph P is defined as P of x equal to -f of x. D, which is k minus 1, lies on P. Determine the values of k in the interval x in element from 0 to 180. So the first thing, let's have a look. P of x is equal to -f of x. That means P of x is equal to -2 sine 2x. All right, so that's our new function, P of x. Then they tell us that point D lies on this graph. That means if I look closely, here's my x value and here's my y value. So essentially, they're giving us what my P of x value is. So -1 is equal to -2 sine 2x. Now if I divide both sides by 1, I get 1 equals to 2 sine 2x. Now this here happens to be your f of x. And this is a horizontal line, like we did in the previous one, passing through 1. So essentially what they want us to find is, what is this value here? What is this x value here and this x value here? So when is 2 sine of 2x equal to 1? So we can do this quickly. If we have 2 sine of 2x equal to 1, I'm going to do this like we do grade 10 equations. Sine of 2x is equal to half. So that means 2x is equal to 30. And x is therefore equal to 15. So this x value is 15 degrees. I mustn't forget that there's another x value here that I need to find. But just like we did so with symmetry in the last question, if this is 15 degrees away here, that's 15 degrees away there. So 90 minus 15 is 75. And those are your two angles, 15 degrees and 75 degrees. (6.5) Graph H is obtained when G is translated 45 degrees to the left. Determine the equation of H and write your answer in its simplest form. All right, so let's write down the equation of G. So G of x is equal to negative cos of x plus 45. That was given to us. And now we're saying that h of x is this graph translated 45 degrees further left. Now this is already a horizontal shift to the left of original cos graph. All right, so this time I'm going to go negative cos of x plus 45, which is the original graph, and another 45 degrees, which takes us further left. If I was moving to the right, then that would be a minus 45. So that simplifies to negative cos of 90 plus x Interesting. Okay, now there's two things happening here. We've got a complementary angle, so we know that that cos has to change to sine. I know that's going to happen for sure. So it's going to become sine of x. Now, let's look at cos of 90 plus x. Cos of 90 plus x is in quadrant 2. Cos is negative in quadrant 2. So we already have a negative from the original. And now it becomes a negative again because cos is negative in quadrant 2. So that would simplify to sine x. So if we take the graph of G and we push it further to the left by 45 degrees, then this intercept sits here. And you end up with a nice sine graph all over again. Question 7. In the diagram, S, T, and K lie in the same horizontal plane. That means think of it as flat on the ground. RS is a vertical tower, so from the ground up. The angle of depression, so this is a horizontal line, and the angle of depression looking down is beta. TSK is this angle here, is alpha. TS is P meters, and the area of the triangle STK is Q meters squared. All right, 7.1. Determine the length of SK in terms of P, Q, and A. So they want the length of SK. The fact that they gave us the area, I know I'm going to have to use the area rule. So in this triangle, the area of triangle STK is equal to a half ST times SK times sine of the angle TSK. And we've been given all the pieces of information that I need to find SK. So the area we know is Q. We know that ST is P units. We don't know SK. We're actually finding SK, so I'm leaving that as SK. And sine of angle TSK is actually sine of alpha. So we've now introduced all the variables that they wanted us to use, and we just have to solve for SK. So all I have to do is take everything else over onto the other side. So Q over half P sine alpha is equal to SK. And to neaten up, I will tip and times to give me 2Q over P sine alpha is equal to SK. And that's your answer. 7.2. Show that RS is equal to 2Q tan beta over P sine alpha. Now, if I look at RS is sitting here. I know what SK is, and the beauty is this is a right-angled triangle. I'm only missing where beta comes from, but if I look closely, remember this line here is parallel to that. They're both horizontals. I know it doesn't look like it is, but they're both horizontals. And this angle of depression is actually equal to this angle of elevation because those are alternate angles. So if that angle is beta, so is this one. So if you look closely, if I draw this triangle now, I have R sitting here, I have my 90 degree at S, and I have K there with my beta sitting in here. Then I've already worked out that SK is equal to 2Q P sine theta. So I've got SK and I've got beta. That means to find RS, which is opposite and adjacent, I have to use a ratio of tan. So tan of beta is equal to opposite, which is RS, all over SK. And we've worked out SK before in the previous question in 7.1. I'm going to move the SK over onto the right, onto the left-hand side, so that I can have RS on its own. And now I'm going to substitute 2Q over P sine alpha times tan of beta. And that's exactly what we were supposed to solve. 7.3, calculate the size of A if A is less than 90 and RS is 70, P is 80, and Q is 2,500 square meters, and B is equal to 42 degrees. The beauty of all the information given to you is that they are filling in all the variables here, except for alpha, and you have RS. So let's fill in the information. I have Q to be equal to 2,500. I have P, which is equal to 80. I don't know alpha, so that stays sine alpha. I know beta is 42, so that's tan of 42. And I know that RS is equal to 70. So if I want to rearrange this, I have 2 times 2,500, which is 5,000, times tan 42, all over 80. Now watch what I'm going to do. I'm going to take the sine alpha over onto the other side so that I can isolate it, and I'm going to move the 70 to the bottom. So let's go to the calculator. Let's go back into computational mode. Fraction, 5,000 over 80 times 70 times tan of 42. You could have put that at the top as well, that's fine. And I get a nice little number here. I'm not going to do anything with it yet. I'm going to go shift sine because I'm wanting to get rid of sine so I can get alpha on its own. Off my answer, that's my previous answer, and I get 53,51. So alpha is equal to 53,51 degrees. Question 8.1. In the diagram, O is the center of the circle. Use the diagram above to prove the theorem which states that the angle subtended by a chord at the center of a circle is equal to twice the angle subtended by the same chord at the circumference. That is, prove that TOP is twice TKP. So this is your bookwork type question. You will be required to prove a theorem in the exam, and this one is one that comes out quite commonly. So there's a simple strategy to this. I'm going to go through the strategy and then write down the proof for you. So the first part of the strategy is to construct. And the first thing you will construct is a line passing from this point K through the center and working across. What happens when you do that? It splits angle K into 1 and 2, angle 1 and angle 2, and also splits angle O into 4 angles, but I'm focusing on O1 and O2 for now. All right, then here is the strategy. If this is the center of the circle, it means that all these lines happen to be equal to each other because they are the radii, making two isosceles triangles. If this angle here is equal to x, then so is that. And if this angle here is equal to y, then so is that, making angle K x plus y. Now we need to find the relationship between these two. If you isolate triangle OPK and look at the exterior angle of that triangle, x plus x is 2x, will go in there. And similarly, y plus y is 2y, will go in there. So we have this angle, which is 2x and 2y, and this angle, which is x plus y, making this double that. So that's the strategy. Right, how do we set out the proof? Here is the layout of the proof. So the first thing you're going to do is to tell the person marking this that you are constructing. You are drawing in a line. So the construction is you're going to draw KO produced. That means you're going to draw K to O, but you're going to extend it further than O, and that's what we did. We joined K to O, and we extended it. That's what produced means. Right, then we labeled O1 and O2 and K1 and K2 on the diagram. As long as you label it on the diagram, then we know exactly which ones you're referring to. So from there, you're going to go O1 is equal to K1 plus T. So O1 was K1 plus T, and the reason is exterior angle of a triangle. But we know that K1 is equal to T. Angles opposite equal sides. Or you could say isosceles triangles, but angles opposite equal sides is more accepted. Right, then we can safely conclude, therefore, O1 is twice K1. Right, similarly, if I want to work out O2 now, remember O2 was equal to K2 and P. So O2 is equal to K2 plus P, also exterior angles of a triangle. But we know that K2 is equal to P. Again, angle opposite equal sides. Therefore, O2 is equal to twice K2. That means if I add O1 and O2 together, remember we split it to start with, that's the same as saying 2K1 plus 2K2, which is equal to 2 times K1 plus K2, which is in fact telling us that angle TOP, which is O1 and O2, is equal to twice TKP. And that's it. That's your proof. (8.2) In the diagram, O is the center of the circle. ABCD is a cyclic quadrilateral. OB and OD are drawn. If O1 is equal to 4x plus 100, so let's put that in, 4x plus 100, and C is equal to x plus 34, calculate, giving reasons, the size of x. All right, the first thing that's glaring at me is that this angle is definitely related to that angle. So I can safely say that angle A is half of angle O1. So A is now 2x plus 50, which is half of 4x plus 100. And that is because the angle at center is equal to 2 times the angle at the circumference. Right, that's the relationship. All right, the next relationship is that opposite angles of a cyclic quad are supplementary. That means they add up to 180. So if I take angle A and I add it to angle C, I must end up with 180 degrees. And that is, oopsie, getting carried away with my keyboard here, opposite angles of a cyclic quadrilateral. All right, now if you look closely, all I have to do is substitute all those x values in. So A was 2x plus 50. C was x plus 34. Right, and we've included all our reasons. So all we have to do is solve for x, and x happens to be 32 degrees. Question 8.3. In the diagram, O is the center of the larger circle. OB is a diameter of the smaller circle. Chord AB of the larger circle intersects the smaller circle at M and B. So this is basically what they're saying. Here's the big circle. That circle has a center O. Here's the little circle. It has the diameter given to us. And then we have a chord AB that intersects both circles. Question 8.3.1. Write down the size of angle OMB. Now you're going to go and say it's 90 degrees because that is your line from center to the midpoint of the chord, but they haven't said that M is the midpoint of the chord. So here's the other reason. If this is your diameter, then this is your semicircle. And your angles in a semicircle is equal to 90 degrees. So therefore M or OMB is equal to 90 degrees. And your reason is angle in semicircle. All right, let's have a look at 8.3.2. If AB is the square root of 300 units, so AB is the square root of 300 units, and OM is 5 units, so there's 5 here. Calculate, giving reasons, the length of OB. So they want the length of this diameter. All right, we've just proven essentially that that's 90 degrees. And if that's 90 degrees, then the line from center that is perpendicular to the chord bisects the chord. So we can safely deduce that AM is equal to MB, making MB equal to half of the square root of 300. So if I write that down, MB is equal to the square root of 300 divided by 2, and the reason is line from center perpendicular to chord. So you've used the reason that it's perpendicular. That's why I can cut the chord in half. All right, if you simplify this, you end up with 5 root 3. So now I have this side to be 5 root 3, and therefore I have a right angle triangle, and we can work out OB using the theorem of Pythagoras. So OB is equal to the square root of 5 root 3 squared plus 5 squared, and the reason is the theorem of Pythagoras. All right, and using your calculator, you end up with OB equal to 10 units. Question 9. In the diagram, ABCD is a parallelogram. All right, so all those opposite sides are parallel to each other. AB is equal to 14 units. So AB is equal to 14 units. So let's put that in. AD is produced to E. AD is extended to E. AD is to DE is 4 is to 3. So that's 4x and 3x. Remember, these are not measurements, 4 centimeters and 3 centimeters. This is a ratio that's been simplified. So it could have been 8 and 6, for instance. So we put in an x to show that there's a multiple that we have to multiply by to get the actual measurement of that side. EB intersects, so EB intersects DC at F, that's that point there, and EB is equal to 21 units. All right, so now this is a measurement. So I know that EB is 21. All right, they want us to calculate in 9.1, calculate with reasons the length of FB. Now, let's have a look at FB. We know that this line is parallel to that, and since we have the ratio of ED over DA, because of the theorem, the prop-intercept theorem, we know that this is also cut in the same ratio. Now, I can't use x's because the length is different, but the ratio is the same, 3:4. All right, so if there's 7 parts making up EB and only 4 parts that I need to find, I can use the 21 to get where I need to be. So let's structure this. So FB over EB, that's the whole length. So FB, which is this length over the whole thing, is equal to DA over EA. And we call that the prop-intercept theorem because DC is parallel to AB. It only works because those two lines are parallel. So let's put in the information that I have. FB, I don't know. That's what I want to find. I know that EB is equal to 21. I know that DA is equal to 4x. And EA is equal to 7x. So FB is equal to 4x times 21 over 7x. My x's will cancel out neatly, and FB works out to 12 units. (9.2) Prove with reasons that triangle EDF is similar to triangle EAB. So let's have a look at which two triangles I need to work with. I need EDF. There's a triangle here. And then I'm working with triangle EAB. Well, the beauty is, as soon as I highlighted it, I can see that E is common to both triangles. Right, so to prove similarity, your layout has to be really, really, really good. And you've got to make sure you reason out your proof adequately. So the structure is, state which two triangles you're working with. So in triangle EDF and triangle EAB, now I need to find 3 angles that are equal to each other. The first angle was obvious. E is in both triangles, so E is common. So that was simple. Now we need to find 2 other angles. Right, so if we look closely, angle EDF, that angle that I've marked, is actually equal to EAB. And the reason is they are corresponding angles. Corresponding angles are equal because DC is parallel to AB. Now all I need is a third angle. Some teachers will tell you don't have to do your third angle. I prefer if my kids do their third angle. It means they've structured their proof adequately. So my third angle is angle F there and this part of angle B. Now there's 2 reasons we could use here. So we're saying that angle EFD is equal to angle EBA. And we could use corresponding angles again. Or because I've got 2 pairs already, I can say remaining angle, or I could say third angle. But I'm referring to the fact that the angles in the triangle add up to 180 degrees. So you could even use angle sum of triangle if you wanted to. So here's the important part. When you're naming your triangles, you've got to make sure that the angles match up. So angle EDF or triangle EDF is similar now. And let's make sure E and E were equal. So E and E will match in terms of their position. Angle D was equal to angle A. And angle F was equal to angle B. So that's how I know they match up. And the reason is angle, angle, angle. There are 2 reasons or 2 sets of ways in which you can prove that 2 triangles are similar. One is that they're equiangular, or all 3 sides have the same ratio. They are proportional to each other. 9.3. Calculate with reasons the length of FC. All right, I'll get to FC in a bit. It's outside of the two triangles I've worked with, but I'm sure I can get there. I do know that AB is 14. They told us that at the start of the question. That means DC is also 14, and that's because they're opposite sides of a parallelogram. Okay, so if I work out DF, I will then be able to work out FC. So let's try and work out DF. The beauty is I've just proven that this little triangle is similar to the big triangle. And I've got the ratios of the other sides of the triangle. So if I look closely, I know that because triangle EDF is similar to triangle EAB, I can pull some ratios from there. I can say that ED over EA, that is ED over EA, is equal to DF over AB, and then EF over EB is the last ratio. All right, let's see what I have. Do I have ED? I have ED. ED is 3x. I don't have to have actual lengths, but I have a ratio. Do I have EA? Absolutely. EA is 7x. Do I have DF? I don't have DF, but I want to find DF, remember? Because DF is going to help me find FC. Do I have AB? Absolutely. So let's substitute those values in. ED was 3x. EA was 7x. DF I don't know, but I do know that AB is 14. So if you work out DF, remember those x's will cancel, move the 14 across, you end up with DF equal to 6 units. Therefore, FC is equal to 14 minus 6, which is equal to 8. And the reason here is opposite sides of a parallelogram opposite sides of a parallelogram are equal. Question 10. In the diagram, PQRS is a cyclic quadrilateral such that PQ is equal to PR. So PQRS is your cyclic quadrilateral, and then they say that PQ, which is here, is equal to PR. The tangents to the circle through P and R meet QS at A. So what does that mean? It means that we have two tangents, one here, and it meets QS at A. RS is produced to meet tangent AP. So RS is produced to meet tangent AP at B. And PS is produced, that means produced to meet tangent AR at C. PR and QS intersect at M. So we've got a point of intersection here. All right, let's have a look at the first question. Prove giving reasons that S3 is equal to S4. So let's have a look. S3 sits here and S4 is there. So we want to prove that they're equal to each other. What I like to do is maybe call one of them X and see what happens from that point on. So let's call S3 X and find other angles that are equal to X, and hopefully we'll get to S4 being X as well. So if S3 is equal to X, and they told us that this here is a cyclic quadrilateral, then if S3 is equal to X, then Q1 and Q2 add up to X. And that's because it's an exterior angle of a cyclic quad. Right, what else do we know? We also know that PQ is equal to PR. So if this angle is equal to X, this angle is equal to X because that's an isosceles triangle. So angles opposite equal sides are also equal to each other. And then the rest is actually quite straightforward because if you look closely, angle R3 is subtended by P and Q. That means P and Q meet at R3, and P and Q also meet at S4, making that equal to X. So by the looks of things, we seem to have all the information we need. Now it's about setting it out. I'm going to do it on the slide here so that you can see it as I go along. So the first thing I said was let S3 equal to X. Right, once we did that, we said that therefore angle PQR is equal to S3, which is X, and the reason is exterior angle of a cyclic quad. All right. The next thing that we noticed was that PR is equal to PQ, and we know this because it was given. And from that deduction, we can say that therefore angle R3 is equal to angle PQR, and that's angles opposite equal sides. And that means we have another angle equal to X. Then the last deduction that we made was that angle R3 is equal to S4 because of the angles in the same segment. So S4 is now equal to R3, which is also X, and that's angles in same segment. Therefore, if you look closely, we've got from S3 all the way down to S4 all being equal to X. So therefore S3 is equal to S4, and in this case we named it X. Question 10.2. Prove that SMRC is a cyclic quadrilateral. SMRC is cyclic. We are looking at that quadrilateral there. So there's lots of ways to prove that it's cyclic quadrilateral. One is that we prove that the opposite angles add up to 180. We can prove that the exterior angle of the cyclic quad is equal to the interior opposite angles, or we can show that the angles in the same segment are equal. But we don't have angles being subtended by the same chord in this particular case. So it's either opposite angles are supplementary, or the exterior angle of a cyclic quad is equal to the interior opposite. Now we have some X's filled in, and I fill that in on purpose, and I want to see if I can deduce anything using the information I have. What I do have is I've noticed that they've given this to be a tangent. Now, whenever they give us a tangent, there's a few theorems that come into play. Line from center perpendicular to tan, or we can have the tan chord theorem. I'm safely assuming that the tan chord theorem applies here. So if AR is my tangent, then this angle lies between the tangent and the chord. This is your chord, is equal to this angle here. So coincidentally, R1 plus R2 equals to PQR, which is also X. And if you look really closely at my green cyclic quadrilateral, let me just move my tangent out of the way. And my quadrilateral, if you look at my quadrilateral, I have this equal to X. And if I extend my quadrilateral here, I have the exterior angle also equal to X, and that makes it a cyclic quad. So how do I set out that solution? Well, the first thing I said was that angle R1 and R2, so I can call it angle CRP, is equal to PQR, and that's tan chord theorem, right? But angle PQR was equal to angle S4 because we proved earlier. All right, therefore, angle CRP is now equal to angle S4. So now we can safely deduce that SMRC is a cyclic chord. And the reason is that it's the converse exterior angle of a cyclic chord theorem. Done. All right, 10.3, prove with reasons that RP is a tangent to the circle through P, S, and A. So here's P, S, and A at P. So basically they want us to prove that this line here is a tangent to a circle passing through those points. So essentially they want us to prove that this angle is equal to that angle. So here is my strategy. I know that S3 and S4 are equal to each other. I know that S3 is the sum of these two angles because it's an exterior angle of the triangle. And I know that S4 is actually the sum of those two angles. Now, if I can prove that P2 and R1 are equal to each other, then A2 and P2 will be equal to each other. So here goes. I'm going to write on the side again. So the first thing I want to say is that angle S3, which is angle S3 here, is equal to R2 and P2. And that's because it's an exterior angle of a triangle, right? Then I show you that angle S4 is equal to P1 plus A2. Also exterior angle of a triangle. All right, but we know that S3 and S4 are equal to each other. S3 is equal to S4. How do we know that? We proved it earlier. Right, that means we can safely deduce that R2 plus P2 is equal to P1 plus A2. All right, remember we're trying to prove that P2 is equal to A2. P2 is equal to A2. And in order to do that, we now need to show that R2 and P1 are equal. And that's easy. You see P1? There's your tangent. P1 is equal to R2 tan chord theorem. So R2 is equal to P1 tan chord theorem. Therefore, if R2 is equal to P1, P2 is now equal to A2. Therefore, RP is a tangent and the reason is converse tan chord theorem.